In this movie, I would like to make the bank account application. And I will do this test-driven, which means I will write most of the test code first and only implement the actual methods or the actual implementation later on. However, I will need to start with the actual basic classes, which means I need a bank account class. Okay, like this. And I need it because this one will allow me to create a first test. So let's create a test directory. We have to tell IntelliJ that it is a test directory by marking it as a test sources root. And now we can use Alt-Enter to create a new test. We pick GUnit 5. We can hit the fix button, which means it will now download all dependencies. Okay, what we will do now is create our actual test. So our first test is a test where we will check that a new bank account starts empty. Like this. Of course, for a new bank account, we need a bank account. Assert equals, and we expect it to be 0. For this, the account needs to have a getBalance method, which of course doesn't exist yet, so let's create it. Let's just make Java happy by returning an int. -1 is an int. Okay, like this. Second thing that we need to test is the following. Test depositing money increases the balance. That should be void. We again need a bank account. And account.deposit. If we deposit 25 euros and then we deposit 50 euros, we expect the balance to be 75. Okay. Of course, the method deposit should exist, so let's create it. E is a bad or an ill-chosen name for the variable, so let's call it amount, and let's do nothing for now. Okay. This is the happy part. So if we add or deposit 25 and 50 euros, it should be 75. There is one exception where deposit should not be allowed to work, which is when you supply a negative number. So depositing negative amounts. Negative amounts is not possible. Which means that if we have a bank account and we deposit 100 euros, and then to the same account we deposit -10 euros, we still expect it to be 100 because only the first one should be working and the second one should not be allowed. Why? This is what they call theft. Should do nothing. Okay. I'll remove the theft because it's not completely true. It's the case in withdraw. Okay, so the next one is a new test where withdrawing money should decreases the balance. For this I made a typo. So for this, we need a bank account, of course. In order to withdraw money, there needs to be money on the bank account first. So let's create one with 100 euros. And now let's try to account withdraw 25. This means we expect the final balance to be 75. The method doesn't exist, so let's create it. Again, amount is a better name. Withdraw is written with a typo, so let's fix it. Okay. Withdrawing negative money, negative amounts should not be possible. So withdrawing negative amounts is not possible. So if I would do minus 15, it should still be 100. Okay. And here we have we need an extra test. Why? Because there is also the case where the current balance is not sufficient to withdraw any money. So withdrawing more money than there is available is not possible. So if we have an account of 100 and we try to withdraw 115, it should still be 100. Okay. Let's create a new test. Void transfer money. Of course, for transfer money, we need two accounts. One is the source account. The other one is the target account. Let's give 100 euros to the source account. And now let's transfer transfer to the target account 25 euros. Of course, this should be an existing method. Okay. And if everything works out as we expected, we could do it like this. So then the source account should have 75 euros and the target account should have 25 euros. Okay, like this. Of course, we are in the same situation where you cannot transfer negative money amounts of money. Transferring negative amounts is not possible. Okay, so we need two accounts again. This time I'm going to transfer from the source, transfer to the target, and I'm going to transfer minus 15 euros. And we expect the source account to still be at 100 and the target account to be still at 0. I forgot an R, so always fix your typos. And the next one is the same as here. So that's transferring more money than there is available is not possible. So again, we need two accounts, and this time I'm going to try and transfer 115, and it should also do exactly nothing. So if we run the tests, we see that nothing works, right? The only thing that's working, or the only thing that's correct, is that this is legal Java. So there are a few extra things we could do if we would like. And that's the following. We expect certain methods, they're able to fail, which is withdrawing and transferring, and they can fail because there could be not enough, it's possible that there is not enough money. So let's change it a bit. Withdrawing negative amounts is not possible. So withdrawing negative amounts is not possible. So here we can make a Boolean, which means were there sufficient funds? And this is not longer allowed. Why? Because withdraw doesn't return a Boolean. So we can just Alt-Enter and make it return a Boolean. And in this case, we expect it to be false. So assert false, like this. Or let's call it success. Same here. And if we do it there, then we should put it here as well, where it succeeds. So here we don't assert false, but assert true. Okay, like this. That means it could fail the same way in transfer. Same problem, transfer should then return a Boolean. Do it like this. This is the one where we expect it to work. So assert true success. So assert that it was a success. And here it should not be possible, which means we assert for false. Same here. Okay. So we run, and of course nothing will be correct. But again, we leave our program in a valid Java state. Okay. So next thing, so now we describe what we expect our application to do. We could also add a final test, which says void the owner's name and age are preserved. With that I mean that actually we should create a bank account based on its owner. But here we have a problem that the class person doesn't exist, so we can create it. Okay, like this. And actually we should supply the owner to the account. But this isn't possible because this constructor doesn't exist, so let's create it. Owner initial owner okay, perfect. We can ignore this for 1 second. But of course, this means that if we supply the owner to the bank account, now we have to supply it everywhere. So let's update it in every test. And we will see better techniques for this later to not have to copy paste all the time. But the important thing is that we leave our program again in a valid Java state, which it is not at the moment, because we're calling a constructor that doesn't exist yet. This is source. Oh, here we need two owners. The source owner, and they can be the same, but they could be another one as well. See, and that's the effect of one small, tiny change in your application. It's possible that you have to fix it everywhere. Okay, so we already have one test that's succeeding. Why? Because it doesn't do anything. So what we expect, assert equals that if we ask the account, get me your owner, and we get the name, then it should be John. And if we ask the age, well, of course, first you need the method getOwner in the bank account, and it should return a person. Right. And this means that a person needs a method getName and a method getAge. Okay, like this. So now we have the actual valid Java code, and we run, and we don't have any methods that are actually working. Okay, so let's try to fix it, and let's start with the easy part. Of course, a person, if we should be able to get a name and an age, then of course the name and the age should be fields. If we create these fields, they should be private, like this, and we could create them in a, we could create a constructor like this, public person, string initial name, and int initial age, name equals initial name, and age equals initial age. This means we get into trouble here in the bank account application. Why? Because now we of course need to use the new constructor, and we expect it to be John of 23 years old, and let's add it to all. So if we would have started with the person class, of course, we wouldn't have to do the copy pasting right now. Let's call them John and N. Oh, no, I think it's Jane. So let's call them John and Jane again. Okay, like this. Let's rerun the tests. We still have none of the functions working. So now let's get started with the bank account, and let's start maybe with the easiest one. If we have a bank account, we first need to know, or we first need to store the initial owner. So owner equals initial owner. Of course, then this needs to be a field. We don't know what final means, so I'll remove it. This is an unused thingy. And then of course we have this getter for owner, and we can just return him or her. And let's run the application, and we will see that we already have one test which succeeds. The owner's name and age are preserved. Why and how this works is something we will study later on. Next step is of course that a bank account does not only keep track of the owner, but it also keeps track of the balance. And let's use int for balance, and you could pick many more examples. And let's start the balance with 0 all the time. Of course, the getter then should just return the balance. And let's see what happens if we rerun the tests. Like this, a new bank account starts empty. That's fine. Let's now implement deposit. Well, to deposit, that just means take the balance and increment it with the amount, the given amount. See? Okay, so now it seems like this method already works, or there's a whole bunch of things that already work, but these are not working. And we will see that if we fix, for instance, withdrawing money, all the other ones will go bad again. So it doesn't mean that if your test succeeds, that your code is correct. So let's go to withdrawing money. So withdraw, what does it mean? It means that if you take the balance, you should subtract the amount, and in most cases this will be a good situation. So let's run the application. We see that we are in the opposite situation as previous, so most of the things are broken now, and withdrawing money decreases the balance is now working. So withdrawing negative amounts should not be possible. That's not yet fixed, so let's go to withdraw, and it tells me that negative amounts should not be allowed. So if amount is less than 0, let's use system.r. This is not possible, and in all other situations we're just going to do what it used to do, except here we return false because it didn't work out. So let's run the application or run the tests, and we see that withdrawing negative amounts is not longer possible, but withdrawing more money than there is available is possible. So let's add a second else if case. If the amount is larger than the balance, we can do this. So either you merge those two cases because they're doing the exact same thing, or you change their bodies. So this is not possible. Let's say negative amount. This is not possible. Amount is too large. Okay, let's run the test again. And now we see that everything works except for depositing negative amounts is not possible. So let's go here. If amount is less than 0, else do the actual computation. It's not possible. This is not negative amount. Okay, perfect. So let's go to transfer money. Transfer money doesn't work, so let's check the test. Okay. The reason is that it is not yet implemented. So let's make it a true. What does it mean to transfer a certain amount? It means you have to withdraw from yourself, and to the target you should deposit the same amount. Okay, let's run the tests. We see that the transfer money function or method now works, but apparently the other two are still broken. Okay, so here we expect a false, and apparently it's still returning a true. Why is this? Because this should succeed first. So let's see. Withdraw was successful. Typo. Okay, like this. If the withdrawal was successful, then we should do the deposit and return true. Else, this means the withdrawal was not successful. That means the whole transfer is not successful. Return false. Run the application again. And now everything works. And this is what they call test-driven development. I wrote, the biggest part of the code was writing tests first, and then I kept on writing code to make the tests succeed.